Hello everyone. On this occasion, I will present the thesis for the final semester in English 2 course. This presentation about is SCWB strong cognitive analysis on the structure designs of the VII Regional Branch Office Building. First of all, my name is Muhamad Fadhilah, and I am a 6th specialist studying majoring in civil engineering at the Garut Institute of Technology with name 21-11-115. You can see the table of content is chapter 1 introductions, and chapter 2 is literature review, chapter 3 is research methodology, chapter 4 research applications, and the last one, chapter 5 is conclusion and suggestion. Chapter 1 introductions. The first one is the background. Office building very at risk of natural disaster. Might one being an earthquake because many buildings were destroyed when they were hit by an earthquake. One aspect that is particularly relevant in efforts to improve building safety from earthquakes is the SCWB, or strong column big beam principle. And the next one is problem formulations. How to analyze SCWB, or strong column big beam, on the safety and reliability of the structure of the Regional VII Branch Office Building, especially in dealing with earthquake loads and other burdens. Next, the purpose of research to analyze SCWB strong column big beam on the security and reliability of the structure of the VII Regional Branch Office Building, especially in dealing with earthquake loads and other burdens. Then, problem limitations. This research will limit the analysis on the effects, the applications of the SCWB on building structures. This research will not discuss the detail of the planning or designs of the overall building structure, but will only focus on the analysis of strong column big beam as one of the structural design techniques on column and beam elements in the building. And next, the benefit of research. For number 1, knowing whether or not the structure is fulfilled with the conditions of strong column big beam. And number 2, can be used as a reference by students in the applications of the strong column big beam method. And the last one, the results of this research can be a guide to improve safety and structural performance of multi-story buildings in the face of earthquake loads and other loads. For chapter 2 is literature review. Strong column big beam. According to Motiatal 2009, the concept currently accepted for seismic planning of reinforced concrete frame structures in the strong column big beam approach. Strong column big beam, or SCWB, is one of the structural design innovations by creating a flexible structural system that is able to deform during an earthquake. This concept is used to ensure that there is no plastic joint in the column during the earthquake, and it is hoped that the column will not fail first before the beam. Based on SNE 2847 2019 and SEI 318 chapter 18.7.3 limits with the sigma MC rather than 6 or 5 sigma MH, which is the minimum permissible limit, where sigma MC is the number of column bending moments, sigma MB is the number of beam bending moments. Moment bearing frame system. According to VII 2015, the moment carrying frame system, SRVM, is one of the main structural systems in resisting lateral force, be it lateral force due to earthquakes and wind. The moment bearing frame system is divided to 3. The first one is SRPMK, or Special Moment Carrying Frame System. The second, SRPMM, or Medium Moment Carrying Frame System. The last one, SRMMP, or Generic Moment Carrying Frame System. Element of structural. In this study, the structural element review are: number 1, column structure. A column is one of the components of a vertical structure that is specially functional to carry offensive axial load, with or without a bending moment, to pass the load to the foundations. Number 2, beam structural. A beam is an element of a building structure that is rigid and designed to bear and hold the load to the column. In addition, the beam also functions to tie between columns so that it is strong from the horizontal parts. Structure modeling. Structure modeling is the process of making a virtual representation of a physical structure in the form of a computer model using software. The purpose of structural modeling is to analyze structural behavior, test designs, and understand the response of structure to a given load. Loading. A load is an external force acting on a structure. The loading used in this study is number 1, dead load, and number 2, the burden of labor, number 3, wind load, the last one, earthquake load. Loading combinations. According to SNA 1726 2019, Article 4.2.2, the effect of one or more non-working burdens must be reviewed. The following is a combination of loading. Number 1, 1.4D. Number 2, 1 times 2D plus 1 times 6L plus 0 times 5 R or R. Number 3, 1 times 2D plus 1 times 6 LR or R plus L or 0.5 W. Number 4, 1 times 2D plus 1 times 0 W plus L plus 0 times 5 LR or R. Number 5, 0.7D plus 1.0 W. Number 6, 1.2D plus EV plus EH plus L plus 7, 0.7, 0.9D plus EV plus EH. Chapter 3, Research Methodology. You can see flow charts in this thesis. Number 1, data collection. Data collections, geometry data, earthquakes, loadings, basic regulations, and literature studies supporting the theory, which have been thoroughly researched. Then, modeling. Modeling with structural analysis software. Next, loading input, then structural analysis, conclusion and suggestions. The last one, evaluation of analysis results. Next, chapter 4, results and discussion. This thesis research locations at Jalan Pendidikan Cibiru Wetan, Cileunyi, Bandung District, West Java. You can see the design first floor building plans in this thesis, then the second floor building plans, and for building data, for building function is office building. For the locations in Bandung Regency, for structure portal type is reinforced concrete and number of floors is 2, and for building height is 10.10 meters. For concrete comprehensive strength or FXLC 25 PA, and for BGTS is 390 MPa. For BGTV is 240 MPa. For column dimension, column 1 is 45 times 45 cm. For column 2 is 35 times 35 cm. And for column 3 is 35 times 35 cm. Then beam dimension for front beam 1 is 25 times 50 cm. For front beam 2 is 20 times 40 cm. For child beams is 15 times 30 cm. For beam bulk is 20 times 30 cm. For subdimension is 20 times 30 cm. For modeling structure, you can open the app, then create a new model. Then set the units to be used, then select read only to enter the coordinates of the column points. Next, enter the point coordinates of the column according to the figure. Then to create a structure material by clicking define and materials, then HG material, then enter the structure material used. To create the structure cross section by clicking define, then section properties, and then frame sections, then add new properties, then select the cross section of the structure used. Then adjust the dimension and reinforcement that will be used on the columns as with beam columns. Just adjust the dimension to the drawing. To create the cross sections of the floor plate, click define, then section properties, and sections area. Then select cell, then enter dimension and material according to the data obtained. The modeling of the column and beam element is done by draw frame or cable element and then adjust to the drawing of the column and beam placement. Modeling of flat element is done by draw poly area, then select any area where there is a floor plate. Modeling of the roof element is done by draw frame or cable element, then make it according to the drawing. Division the cell elements can be done by selecting all the flat elements, then click the designs, then area, then automatic area measurement. In this case, the flat is divided into 6 × 6 parts. The loads entered into the software include dead loads, live loads, wind loads, and earthquake loads. The type of loads acting on the building structure can be input using defined dead load patterns. The dead load is distributed on the flat evenly by selecting the flat element, then design, then area loads, then uniform or cells distributions of the dead load acting on the plate. Based on the calculation of the dead load on the first floor plate, the total is 1.51 kilonewton per meter square, and for the roof plate it is 0.57 kilonewton per meter square. The wall load on the beam is input by design, then frame loads, then distribute. The load is obtained for calculations. For the first floor, this is 9.5 kilonewton per meter, and for the second floor, it is 9.65 kilonewton per meter. Distribution of live loads on the floor is done by selecting flat elements, then design, area loads, and uniform or cell. Live load is obtained for SNE 1727/2020 for office live loads of 140 kg per meter square. Modeling of flat elements is done by draw and draw poly area, then enter the wind load according what has been calculated. To enter the equivalent static earthquake load, click the define, then load pattern menu, then in the SX row, select the auto lateral load pattern column, select IBC 1009, next click modify lateral load pattern, then fill in the parameters. Input dynamic earthquake load spectrum can be done by defines, then functions, then response spectrum, then IBC 2009, and add new functions. IBC 2009 was chosen because the parameters in it are also the same as SNE 1726/2019. This is just into the Indonesian earthquake map chart. And then how to input the spectrum gas switching factor by define, then load gas, then spectrum response, then modify saw or load gas. Defining the structure must define, then must source, then modify or saw must search. For the load combination that will be used when carrying out structural analysis can be done using load combinations based on SNE 2847/2019 article 9.2.1 factor load combination. And you can see the result of the analysis in this thesis. The last one is chapter 5, conclusions and suggestions. For conclusions, based on research that has been carried out on the structure of the regional office branch office ID building regarding the structural strength analysis of the strong column weak beam requirements, it can be concluded that the result of the analysis are there are 9 column points that do not meet the strong column weak beam requirements, namely the column located at the coordinates P2 K1 45x45, P3 K1 45x45, B4 K1 45x45, B5 K1 45x45, B6 K1 45x45, ABA1 K1 45x45, ABA2 K1 45x45, AC-A2 K1 45x45, and AB-A2 K1 45x45. Suggestions in this thesis, suggestions that can be taken from final thesis assignment with the title SCWB strong column-weak beam analysis on the structural design of the Region 8 Bandung Branch Office Building. For other research who are interested in similar problems, the result of this research should be developed considering the limitations of this research with a wider scope, considering that in this modern era many structural design are combined with other structural plans and structural planning for earthquake areas, especially in Indonesia, by following the latest SNE requirements based on its classification in order to produce plans with the latest regulatory standard. Maybe that's the only presentation I can deliver. I'm sorry, there are many errors in the pronunciations words. Thank you and Assalamualaikum warahmatullahi wabarakatuh.